All right, so this is Module 1 review for 7th grade for an exam review. I am going to be kind of going back and forth between your spiral book and your textbook. The biggest thing that we are going to take away from this chapter is a reminder on where science started. All right, so what is science? Where did it start? Who got us to where we're at right now? So the definition of science is the systematic study of the natural world through observation and exploration and experiments. I'm in your spiral on page 22, okay? So we know that science is the study of the natural world around us, and we observe and we explore and we experiment and we make these general laws. That's the definition of science, which you need to know. This is your science class. Now, papyrus was just a form of paper. Why did we need paper? So that they could write things down, the experiments that they made, the things that they did. They needed to write them down. All these old scientists and old cultures needed to write their stuff down so that it could be passed on to generations and passed on to different cultures. So they did that on papyrus. Now, we have ancient times. We've got these old Egyptians, right? So the Egyptians kind of did a lot of trial and error. They collected facts, but they didn't use facts to explain anything. They just kind of figured out what worked and went with it. They didn't try to figure out the reason behind it. Now, there was other cultures as well that we see. There, like the Chinese, we read about them, and the Greeks and the let's stop with Greeks for a second. We're going to talk about Aristotle. So back in the Greek world, let's talk about Aristotle. He came up with this idea of spontaneous generation. So I'm going to remind you, if you're following along with me in your spiral book, I am on page 27. Okay, so I'm in your spiral on page 27, and I'm in your textbook on page 6-ish. I'm in that area. So listen, when spontaneous generation came around, they were trying to figure out how things came to be. Like, why does living things exist? How did this happen? What he saw was old rotting fish, and the fish suddenly had maggots, which are gross, but they suddenly had maggots, and those maggots are a living thing. So how did these living things come out of a non-living dead fish? So he came up with this idea of spontaneous generation, that a living organism can be spontaneously formed from a non-living substance. Well, what he didn't know, would you just go, please? What he didn't know was that there was flies landing on the fish, and that they were laying eggs that were microscopic that he couldn't see, and those hatched and turned into maggots. He missed the whole middle section, right? The laying eggs part. He missed all that. He thought the maggots actually came from the dead fish. So this idea of spontaneous generation, that a living organism can come from a non-living thing, that lasted for a long time, unfortunately. We incorrectly believed that for a while. And then eventually they realized that that was not a thing. So then we've got Archimedes and Ptolemy. So this was the module where we had a lot of old dead guys, right? Like, how did we get to where we're at now was really just from all of these old scientists who were making advances hundreds of years ago. So we've got Archimedes and Ptolemy. Your book goes on, in your textbook, I'm sorry, and talks about Roger Bacon and Thomas Bradwardine and Nicholas of Cusa. We're not going to get into all the details of that. Look at your study guide and you'll see. We're not getting into all the details of that. What I want you to know is that the big picture. What's the big picture? Well, we had this idea of spontaneous generation for a long time incorrectly. Eventually, it got fixed, obviously. And that, this idea of progress really came from people not just having an idea, but experimenting with that idea and testing that idea and trying to prove that idea. So your book in your spiral, alchemists, remember those are the guys that chemistry, they played with materials, they played with the periodic table, they played with chemicals, and they were trying to make gold, fake gold. Because gold was expensive, they wanted to sell it, but they wanted to find a new way to make it. So they were trying to make fake gold. Now we know that that's not possible, but that's what they were trying to do. And what they were really, really good at was documentation. So they were really, really good at documenting what they did so that now we can look back and say, nope, that combination doesn't work. Well, that combination does. And from that documentation, they created all sorts of compounds like salt. Sodium and chloride came from this period of time. And so now we know that we have salt because you can combine sodium and chloride. The two big things, I'm in your spiral book on page 30. The two big lessons that we take away from the alchemist time, which I believe was what, the Dark Ages, right? So what we take away from that is that progress depends on the government. Now, what that means is if the government wants something to happen, they are encouraging and paying people to make that progress happen. They're funding the research. That still happens now. Why do we even have people in space? Why did we have NASA? NASA was a government funded program. The government wanted us in space, so they created a budget to send people there, which included obviously making spaceships. So NASA was a funded project by the government. So progress always depends on the government, and it depends on other scientists. Remember? So instead of just starting from the basics every time, we always take what was previously learned by old scientists and we work on that. We take their notes, we take their experiments, we take their research, and we build on that and we learn from that so that we don't have to start from square one every time. Now, there's other, your book and your spiral book goes on into this Roger Bacon and Thomas Bradwardine. Thomas Bradwardine, by the way, is who proved Aristotle wrong about spontaneous generation. But we get into this idea of what's happening not just on Earth, but in space. So that we're round, that we are orbiting the sun, that everything is not going around us, but that we are all going around the sun. And we have a much better idea of what's happening in the whole universe now based on those scientists. Now, turning the page in your spiral to 34, now we're getting into the golden age of science. We've got Galileo and all of his ideas. He invented the telescope. That was a very big invention. And then we get into a set of gentlemen. So we've got Copernicus, Vesalius, Johann Kepler, Galileo Galilei, and Blaise Pascal. So now we are running through science at this point. And science and math exist simultaneously. So Pascal is talking about atmospheric pressure and all that kind of stuff, but he's also inventing Pascal's triangle and all of these math equations and formulas and rules that we still follow today. Then we get into the era of Newton. So in your spiral, I'm on page 36. Now we're talking about Isaac Newton. Dude, bomb.com of science, right? Like, he has scientific laws all over the place. So we've got the laws of gravity, we've got laws of motion. He is coming up. He's not just, he's realizing it exists and then proving it in a way to it become a law. He's got the law of inertia, all of these things. So Isaac Newton, pretty big deal. He is really the foundation of like modern science in terms of what we follow today and what laws creation follows. Robert Boyle is who founded chemistry. Then we've got Anton von Leeuwenhoek. Now, he is important because he discovered the microscope, or he created the first microscope. That's an important note. We don't know microscopic things unless we have a microscope. So that was an important one. And then it goes on to the Enlightenment period. And what we realized during the Enlightenment period was that science, we stopped relying on old scientists' work just because they were famous. And we started actually testing and relying on proven data. So there was this shift, this change, and instead of just saying, yeah, we believe this because Aristotle said it or Einstein said it, now we believe it because the data says it. We've tested it over and over and over again. And so thankfully, this Enlightenment period really shifted from relying on credibility. Instead, now we're relying on the data, which sent us right into the Industrial Revolution, which was really important because that's where we came up with the assembly lines and mass production of different things, and the ability, instead of it just being everything being, think about this. It's Christmas time, right? Everybody's doing Christmas decorations. Everybody's got some sort of maybe lights on their tree or ornaments on their tree or a string of lights outside or a net of lights on their bush, who knows? But you can all picture these types of ornaments. Imagine if everything that you had to be handmade just for you all the time. That takes a lot of work and a lot of money, I might add. So this Industrial Revolution was the ability to take one idea and mass produce it now. So now everybody can have lights on their house and everybody can have that ornament, and it's cheaper to own these things. It's cheaper to buy them because now we're mass producing them. So the Industrial Revolution was incredibly important for life and progress. The problem that happened in this period, as we moved towards this really great Industrial Revolution movement, we moved away from, up till now, science was for the purpose of proving God and showing proof of his existence and showing facts and evidence that supported scripture. All these guys were most of these guys, I should say, were all Christians, and they had this Christian worldview. But as we move into the Industrial Revolution, we got out of that, and it wasn't church-based anymore, and it wasn't for the purpose of explaining God's creation anymore. Now it was simply for the purpose of just progress, and then anybody could do it. So that was obviously a big downfall. Then we see Linnaeus and Lavoisier and Dalton. Linnaeus, remember from last year, he's who gave us the classification system. Kate poured coffee on Father's good suit. So that was a big thing. Then we get into the most recent section of time, and that's Darwin and Pasteur. Now, Louis Pasteur, he's important because of immunizations and shots. He pasteurized our food. He is who created the ability to find bacteria in food and be able to protect us from that. Then we get into, let's skip over to page 41, Niels Bohr, Albert Einstein. So now we're getting into the atom and what the atom looks like and the model of the atom. Remember, Niels Bohr gave us what protons, neutrons, and electrons look like. So now we're not just saying, sure, non-living things can come from, or living things can come from non-living things, and I think everything revolves around the earth. Now we're like matter and atoms and molecules and particles, and it's much more intricate science. Modern science is what that is. So that's all of module 1. On your exam study guide, you're going to see that there's questions about the definition of science, the definition of spontaneous generation. There are questions about Egyptian scientists were known for their process of what? Trial and error. We said that earlier. The world's first real scientists are considered who? Are they the Egyptians? Are they the Greeks? What did we just say? What worldview replaced the Roman worldview? So those are all things that are in our spiral. And since we still have some time, I'm going to go ahead and find it. If you are following along with me, I'm looking for the page number. All right, the Christian worldview to replace the Roman worldview. So if you did not print off your paper yet, actually, I think that might be module 2. I think I might be just a little ahead of myself. Yes. So we'll get to that tomorrow for module 2. And then it also talks about what should scientists do when researching. We're going to talk about that a little bit tomorrow. There's also some questions on your, oh no, that's also tomorrow. I'm just getting ahead of myself, aren't I? Okay, so listen, tomorrow, when we do module 2, we didn't do module 2. I kind of skipped module 2 in terms of our actual book work goes. I spent a day just talking about it briefly and the important things that were in it. So those are the only things that I included in your study guide. So tomorrow's is gonna be shorter. But your module 1, we skimmed through. Your module 2, we kind of skipped. So module 3 is when we start getting into it real intricate. So stay on the Zoom for just a second. I'm gonna stop the recording.